So here's one special case called perfect squares. Let's begin. A perfect square looks something like this. It has three terms. The first and the last are perfect squares, and the middle term is 2ab. But let me explain that real quick. A squared, so the square root of a, and the last term, if you times them together and then times it by 2, you'll get your middle term. So let's see a few examples here. So let's say you have x squared minus 6x plus 9. Before we just look at the answer here, let's try and figure out how we got to that. So square root of x squared is simply x, and square root of 9 is 3. So you get x times 3, that equals 3, times 2 equals 6. But we have minus 6, so we want to just make sure we have a negative there. And then we're done factoring. Let's go on a bit more difficult one. So we have 25x plus 40x plus 16. So square root of 25x squared, simply 5x. 16 at the end is 4. And here's how we find the middle term. So we got the 5x right there. The 4 adds in there. So 5 times 4 equals 20. Times 2 equals 40, so we're good there. So it's simply 5x plus 4 squared. But now let's say we have 2x squared minus 20x plus 50. So does it add up right? No, it doesn't, as we can see here, because 2x squared is not a perfect square at the beginning. But we can take out a common factor, which is very essential and key. So now we got 2 on the outside, and now we have x squared minus 10x plus 25. So right away I know on the outside, in my answer over there, I'm going to have 2 bracket something. So back to here, we have x squared, that's x, 25 squared is 5, x times 5 times 2 equals negative 10, so we know we need negative over there, and now we're done. So that's simply how you do a perfect square.